Hello and welcome everybody to our talk on epidote geochronology and its application to porphyry exploration. This is some work I did during my PhD at Codes a couple of years ago now, and it's just making its way out of confidentiality, so I'm happy to share some of this with you now. It's a bit of a whistle-stop tour, mostly covering off on some nice high-level highlights rather than getting stuck in the nitty-gritty of things, but there's a lot to get through in this kind of 10-minute taster session, so we'll jump right in. I'll actually just turn off my video because it interferes with some of the slides. So to set the scene, we'll be talking about Resolution, a deep, undercover but high-grade porphyry deposit in Arizona. Resolution was discovered somewhat by accident, I guess, during underground exploration around the historic magma epithermal vein mineralization that had been mined since the mid-1800s. And I guess the question was, could we have found Resolution sooner using evidence from surface? This is a nice segue into green rocks, which is an emerging tool developed largely down here at Codes, where the trace element composition of epidote and chlorite is used to vector towards the heat source of a mineralized system. However, in this case, broadly propylitic style alteration is widespread in Superior, which has had a kind of long and traumatic geologic history. So the first question that was raised during the initial mapping and sampling was, is all this alteration related to the Resolution porphyry system? And we initially dated some hydrothermal apatites and titanites with good results, but their limited distribution led us to directly date the epidote to try and better understand the different generations of propylitic alteration in the district. And the results demonstrate previously unknown Proterozoic epidote chlorite hydrothermal event, as well as the younger Laramide ages, with epidote from the Proterozoic and each of the Laramide deposits having distinct trace element characteristics. And in this case, the porphyry-related Laramide epidote is characterized by a strong enrichment in lead and strontium compared to the other phases of propylitic alteration in the district. So where in the world are we? We're in the Cretaceous to Tertiary Laramide arc of the southwestern US, which is well known in porphyry circles. Superior is obviously well endowed with both porphyry and epithermal mineralization, highlighted by the various mineralization shells there on the map. The district exposes a full range of stratigraphy from 1600 to 18 MA with the ubiquitous post-mineral basin and range extension. So the geology of the district dips around 30 degrees east. And just to orientate yourselves on the map there's a sort of gravel-filled basin in the west, a narrow strip of pre-mineral rocks exposed in the west-facing range front that sort of defines the centre of the district. And this is all capped by tertiary volcanics at higher elevations to the east, as you can see there, under which all the mineralization occurs. So we're just going to have a quick look at the Resolution deposit itself. It's hosted in this blind graben containing otherwise unexposed Cretaceous volcanoclastic rocks and underlain by Paleozoic limestones and a Proterozoic basement of dolerites and metasedimentary rocks. And this is all covered, as I mentioned, by a kilometre and a half of gravels and ignimbrite. Discovered in the 90s during exploration around magma, but now has a current resource of 1.7 billion tonnes at over 1.5% copper. So quite a serious deposit and worthy of further investigation. So there's a few examples of the propylitic alteration here in the Superior district. From right to left shows a sort of decreasing intensity of alteration around the Resolution deposit, starting off with strong replacements and moving out to much more sort of selective replacements and minor veinlets. Magma has these epidote selvages around many of the sort of distal veins, and there's a variety of textures and occurrences of epidote chloride alteration at Silver King, including skarns and veinlets, pervasive patches and so on. And that's in the subeconomic Silver King deposit in the north of the district. Out in the country rocks, there's more examples of these sort of skarnoid occurrences, epidote veins of various flavours in the country rocks, patchy epidote, as well as this kind of wispy cleavage hosted epidote alteration. Particularly in one of the Proterozoic basaltic units, epidote chlorite is widespread and highly variable as well. So I guess the reason I'm showing you all this is to really demonstrate that there is this particularly widespread, highly texturally and mineralogically variable style of propylitic alteration that occurred throughout the district. And as I mentioned, the unavoidable question becomes, is this all related to resolution, or is there something else going on here? And I think by now you're probably starting to guess the answer. So as I mentioned, we started by dating out these hydrothermal apatites and titanites, primarily within that basaltic unit I mentioned, where there occur intergrown with epidote and chlorite within the amygdales. But the distribution of apatite led us to really chase the epidotes, as it's a little bit more widespread. But the intergrowth of these two minerals in some samples allowed us the chance to rigorously compare the results of these two different minerals from the same samples, obviously using the same analytical methods. So you can see the apatites and titanites plotted here in grey against the apatites in red and blue. The colours denote the various methods we used. And in some cases you can see that the epidote is actually carrying as much or more radiogenic lead than the apatites and titanites, which in itself is quite unexpected. You can see that the results are quite comparable between the epidote and the apatite, which is really good considering this is a sort of first attempt uranium-lead dating of epidote, especially without a matrix match standard. And that lack of standard is why you can see there's some offset in the ages, around 5 to 10% in most cases. But the key point here is that the ages generally do compare well between apatite and epidote. But the other thing, perhaps more importantly, is that there's two clear age populations evident here. Firstly is the previously unknown Proterozoic hydrothermal event at around 1100 to 1200 MA in the first two samples, and then the much younger 70 to 80 MA Laramide epidote on the right hand side. So this obviously has profound implications for understanding and vectoring in the propylitic halo around resolution using traditional trace element geochemistry. And this epidote geochron allows us to define a training set of trace element mineral chemistry data with which we're confident about the origin of this propylitic alteration. So we can use this training data to classify other samples that have uncertain affinity, no geochron or no confident field relationships. And this classification allows us then to map out the various types of epidote and then to filter out all but the resolution-related signal, for which we can conduct our usual vectoring studies. So this is a schematic plot of the discriminant projection analysis of the training data with the groups that we defined from the geochron and or the field relationships. So you can see the Proterozoic epidotes are enriched in things like boron, uranium, and the rare earths compared to, say, the Silver King samples, which are enriched in strontium, barium, and lithium, compared again to the resolution samples, which are strongly enriched in lead, strontium, and zinc, as you might expect. And so now that we know the trace element characteristics of each of our major groups, we can then go on to classify the unknown samples. And that's the results of which are shown here. For each of the individual spot analyses from each sample is displayed as a proportion of the sample, with the colours sort of denoting the affiliation or different ages and deposits. As you can see, the individual samples generally have these multiple, what you might call epidote types, and at first this might seem unlikely. It would suggest that most of the epidote-bearing rocks in the district have been overprinted by multiple fluids, each depositing their own stage of epidote. So we decided to test this by mapping out some of the samples, and the first cab off the rank now is number 26, a Proterozoic sample from distal to the deposit out in the range front, which made it ideal to go and test this overprinting theory. And in this example, you can see that we've got up to 5 stages of epidote growth, one with early K-rich ratty cores, and then a titanium and greater than manganese growth in the middle of that crystal there, and then a little rim of higher manganese to titanium with a lot of other sort of traces, perhaps a lower temperature stage. And then this very thin light rare earth rind right on the edge of the crystal there. And we interpret these first 4 stages as representing the various stages of hydrothermal fluid evolution and crystal growth throughout the Proterozoic event. But finally, there's this small and intense overgrowth of lead and strontium, which you can see at the bottom of the screen there, which was previously identified as characteristic of the epidotes proximal to resolution, close to the deposit. So This is really providing good evidence of the overprinting relationships within the same sample of these two hydrothermal fluids, which are over 1 billion years apart. So having validated this classification, we're then able to filter out all but the resolution related epidote and chlorite at the district scale, and then we can apply our vectoring approach. And here you can see the results of the green rock vectoring once the unrelated samples have been filtered out. And as you can see, this is highly effective at identifying the resolution mineralization at depth. So there's a couple of summary points here just to reiterate the take-home messages, is that resolution is a deep, high-grade system in Arizona, where green rocks is a valued approach, but in this, as many other ancient basement terrains, propylitic alteration can be widespread and may often confuse the vectoring capabilities. So by directly dating the epidotes, it may be possible to help sort the good from the bad and help filter out the unrelated alteration in your porphyry exploration programs. With that, I'll finish up as I'm running out of time. I know I've been a bit light on the detail here in favour of giving you the big picture, so I anticipate there'll be a few questions and I look forward to hearing them in the panel discussion. Thanks very much.